Hello children, how are you all? Now, in the previous chapter, that is matter in our surroundings, we learnt about matter. Matter, what is matter? The next, what is the composition of the matter? What it is made up of? The next one, the types of matter based on certain physical properties. Okay, right. So the types of matter: solid, liquid, gas. And okay, what are the reasons for these differences? We have seen the interparticle space and interparticle forces. So these are the two which affected the type of matter. Now, this matter, it behaves that it undergoes some changes, right, under certain conditions. That we'll be learning in today's part. In our chapter is matter around us and the types of changes that are taking place in matter. Now, before getting into the detail, I'll do a very small activity. I will easily be able to tell what the thing that I am doing. I'm taking something, a matter, and I am bringing out a small change, and you should be able to tell what type of change it is. Okay, right. Now, you will be able to tell striking differences before and after the change. Right? Okay. Now, children, you notice what it is. What is that, children? That's a paper. What is that? That's a paper. That's a plain paper. Right, good. Now, this paper, it has some particles. Oh, it's a solid. Right, good. Now, I will try to crumple it. So, I've crumpled this paper. I've just crumpled this paper. Now, how is this? It's not like before now. But is it paper? Yes, it is paper. How can you say that this is paper? That is because the particles of this paper have not changed. Okay, right, good. Now, I will try to, this is not a new substance, one. Now, I'll just try to unfold all these folds. And what do I get, children, again? I get the same paper. So if I just soften this, you will get exactly the same paper. There's not much difference between this and that. It's the same thing actually. So we have brought back the original paper as it is. There's not a single difference between these two. So what do we understand from this? So this is this change which happened. That is from being this paper to be crumpled paper and again back is the same thing. So first and the second part and this, there is no change in the material of this matter. Okay, children, it's very easy by simple physical means. That is unfolding here. I brought back this. Okay, and was it permanent? Did it happen so that it cannot be brought back and it remained there? No, it could be brought back. So I say this change is happening only in the outward properties like the structure of this being solid, the crumpling and all. Okay, right. In order to bring this back, did I use a very complex process? No complex process was involved. It's just a simple technique of unfolding. So this change which you can see, it is taking place only in the outward properties. It's temporary and it's reversible. And I did not involve any complicated things like light, heat, anything. So such a change in only the outward structure of matter without the actual inner composition, that is called as, without the change in the inner composition of the material or matter, that I call it as a physical change. What is that? Physical change. Now, observe carefully what I am doing. I take this paper and I take a matchstick. Right? I'm taking a matchstick. Then holding it there. Now I am burning it. You can see, children, you can see clearly that I am burning it. Okay, right. So I am burning the paper, right? So what do you notice? Is there some change? Yes, there is some change. You can see that the paper now it has become ash. The paper has become ash, right? And this ash and the paper, how are they? Are they similar to each other? No, they are not. You can clearly see a striking difference between these two. What is that? Paper, it was white in color, and this ash, it turned black in color. Okay, good. So there is a change in the outward color. Okay, good. But do you know what happens? Now, if I take this, when I supplied it burnt, and when I take this and keep it in a refrigerator so that I can cool it and bring it out, bring all the heat out, what will happen? What will happen? In no way, by any ordinary means like cooling it, I can bring back that paper. So it's a permanent change. And that substance which is formed is totally new. It's not having any characteristics of the first paper. So a new substance is formed here. In this case, second, it's an irreversible change. It's an irreversible change. The change is there, irreversible change. And what more? What more? There's a change in what is called the most important thing, the internal composition of the material. The particle composition in the paper, it was carbohydrate. Now, it is not carbohydrate, but it is just carbon, or otherwise burnt, charred carbon, and a few other things. So what do we understand from this? So we have brought about a change in the paper, but that paper's change is an irreversible change. Irreversible. You just cannot bring back. So such a change where new substance is formed as irreversible. And what did we do in order to bring such a great change from this to that permanent change? How is it possible? How did we do it? We have brought about that severe change by igniting. So we involved a lot of energy, heat, light, absorption of heat energy, light energy. The next one, apart from that, instead of that little bit heat light we supplied, that produced a lot more of heat and light. So there is more of absorption of heat and light. So such changes where the direction is onward, that is new substances formed, it's a permanent change, right? Cannot be brought back, it's irreversible change. A lot of heat and energy are involved. Such change we call it as chemical change. Why? Because there is a change in the internal composition of the particles, or we call it as chemical composition. Such change we call it as a chemical change. Now, we are here to understand what are called physical and chemical changes. We are here to understand what are the different physical and chemical changes that are taking place all around us. So children, in the activity that we have seen, we have understood what a physical change is and what a chemical change is. Okay, we have seen the characteristics of physical change and chemical change. Now, we will see a few physical changes and chemical changes that are happening all around us. Okay, let us go for the physical changes. Now the first one, we have a wax, melting wax. So you take the wax, a little of wax, hold it in a cup and try to heat the cup. What will happen? A steel bowl or something, and heat that. What will happen? Due to the heat, the wax will melt. Wax melts. That is, it has become solid to liquid. Now just keep that aside for some time. What will you observe? You will observe that that liquid wax has again returned to become solid wax. So what did we see? So there is a change, but this change is not permanent again. It's a temporary change. We have brought back the substances just by cooling it. So that's a simple technique of reversal. It's irreversible. It is reversible change. Okay, cool. And did we change the chemical composition of the wax material? No. Why? Because whatever was in wax, the same thing returned. So it's the same thing in liquid as well as in solid as well as liquid. So that's children, this is a physical change. Next, anything else? Okay, right. Take cubes of ice, take it in a cup, place it there. Okay, you may heat it, and what will happen? Gradually, after some time, the whole of the ice it becomes water. Okay, right. Now, if I try to keep this same water in a refrigerator for some time, what will happen? That will again form ice. So what is this? It's a reversible change. And second thing is, the same material remained in it. Whatever was in the ice, the particles of ice, they are there in water also. So that's it. Now here, what did you do? We heated first, later on cooled. A simple technique of reversal has brought back the original substance. It's a temporary change. It's a reversible change. And there is very little quantity of heat involved. Absorption or release of heat energy involved. Okay, children, right. So that is also a physical change. Any more? Are there any more physical changes? Yes. I'll just give you an example. I take some water, put some salt in it, dissolve it, salt is gone. Now salt has changed. Where has it gone? Where has it gone? No, okay, right. I want to get back salt. Is it possible? Yes, it's very simple. What is that? We just heat that water, or say heat that salt solution. Water, it will vaporize off, or you can say distill off, evaporate off. What remains is salt. So there we have not involved any complex process. It's a very simple process, a simple technique to bring things back. So that is also a physical change. Similarly, when you heat water, water again boils off to become steam. While the steam is coming out, just place a plate over it. What will happen? You find that water vapor, it gets condensed and water is formed. So children, reversible, no new substance formed. Simple technique, by reversing the conditions, we can get back the original substance. So it is also a physical change. So children, these are a few examples of physical changes that are happening all around us. Now let us see a few examples of chemical changes. Now I take a matchstick, strike the matchstick, hold it like that, it will burn, right? The next one, I try to put some water on that, try to cool it, or do whatever process. I'm not going to get back the original matchstick. It has become useless, it's dead now. So what is that? There it is. It is a permanent change. One is an irreversible change. And what happened? A lot of heat and light are generated. So there is a lot of heat and light involved in that reaction. So children, we can say it is a chemical change. So just now I uttered a word called as reaction. What is that reaction? A chemical change is also called as a chemical reaction. Sir, why do you call it a reaction? The reason is, here when I struck a matchstick and I kept it there, so the material of the matchstick, under those conditions of heat or the friction that is supplied, what happened was that material, it started taking the oxygen from outside and started burning. So it involved some other substance also. Now when I eventually bring up that matchstick and check, I don't find the same material, because the material, say whatever it was, okay, right, say carbohydrate or whatever in the wood, that got reacted with oxygen from outside and a new substance is formed. So it is an example for a chemical change. Is there any other example? Yes, when you are cooking your food, the composition of it changes. The chemical reactions will happen inside the food so that it becomes something which we can digest it. So that's an example for a chemical reaction. Burning of food, okay, that's a chemical change, chemical reaction happening and bringing about a chemical change. Anything else? Now, come on, think about the very common thing that we do. Take milk, boil it or heat it. When it is lukewarm, add some curd to it. Keep it overnight. In the morning, you get a solidified mass of curd again. What is this? Now, try to bring back milk from it. Can you do it? No, it's not possible to bring that original milk back. So, what do we understand, children? So, curdling of milk is also an example of a chemical change. So children, now we'll just get into the details, but I want to give you a good idea about a chemical change by a very small example here to understand what is called the chemical composition. Now take say hydrogen gas, and this hydrogen gas is a very combustible gas. Highly combustible gas is dangerous, you should not do it, but I'm just giving you an example. So in very small quantities you can do it under surveillance or under the guideship of your teachers. You can observe what your teacher does. Okay, if we take a little of hydrogen gas and ignite it, or take a burning matchstick, put it there, it will say pop, and the flame will be put off. But if you carefully observe the test tube in which the hydrogen gas was, at the top, at the end, at the mouth of the test tube, you'll find fine droplets of water. Do you know where those water droplets have come from? Okay, that is because this hydrogen gas, it has hydrogen particles. Now, when I ignited, and at that temperature, the hydrogen gas which was there, and those conditions of heat, they absorbed oxygen from the atmosphere. The particles of hydrogen reacted with the particles of oxygen, and they formed water. Hydrogen was a gas. Water is now a liquid. So if you think that is only a change of state, so it is a physical change, for information, see the characters of these two. Hydrogen is combustible, but water, it is non-combustible. That itself tells that the substances are not same. So there are two different substances. One, they are new substances. There may be a physical similarity, or it looks as if it's a chemical change, physical change, but it is not so. It is only a chemical change. Now, what differences do you observe? Chemical composition is totally different. Hydrogen, there are hydrogen particles. Whereas water, there are water particles, particles of water. These totally are different. This hydrogen and that hydrogen that is there along with oxygen, they are totally different in nature. They have lost their nature. The bombing nature here of hydrogen, the blasting nature here, burning nature, their cooling nature along with oxygen, and that is used as an extinguisher for fires. So children, right, we understand that burning of hydrogen gas, okay, that is also a chemical change. So there is a change in the composition. Once it goes forward from water again to bring back, you just can't choose which is hydrogen, which is oxygen, and separate them by hand picking or distillation or whatever process. You just cannot bring back hydrogen which has gone into that water. Now what can we do? In order to bring back, there is a process called as decomposition. It is a chemical decomposition or electrical decomposition or electrolysis that is used in order to bring back that hydrogen. It's a very complex process. It's not a simple process. It's not a simple physical process, a physical technique to bring back. So by no physical technique can you bring the hydrogen or original substance back. So children, burning of hydrogen also is a chemical change. So children, we just note down the differences between physical and chemical changes. Right, so physical change, chemical change. What are the differences? One, new substance is not formed here. And there, in that, new substance is formed. This is reversible change. That is irreversible change. Second, heat and light. Here, involved absorption of heat, light, something to minimum most. But a lot of heat and light are generated in that. So, what else can we talk? There's no change in the chemical composition of a substance during a physical change. But there is a change in the physical or the chemical characteristics or chemical composition of the material. There are changes in the physical properties here. There may be changes in the physical properties there also. And anything else? You can bring back the materials here, the original materials, by what is called as simple physical techniques. But in that case of chemical change, no physical technique can be employed to get back the original substances. So children, these are the differences between physical and chemical change. Right, so that's it. And now we're going to talk about some common phenomenon, some common thing in our everyday life where there exists what is called both physical and chemical change. That's an example, right? Okay, take a candle, and that candle, if you keep it there, ignite the wick, what will happen? What will happen, children? Okay, the wick will start burning. Okay, good. But during that heat, due to the heat, the wax starts melting. What will happen to this wax? It is melting. So melting. So solid wax is melting. What type of change would you think it is? Do you think it is? It is a physical change. Solid to liquid. Right. Good. Now what else? This liquid, it seeps or passes through the wick by capillary action. And when it goes up, due to the heat, it starts becoming vapor. So what changes this? Yes, it's also a physical change. Very good. Now, the final change. We'll see the final change. The vapor, it catches fire. And that starts giving a flame, a bright light, a lot of heat. So, what changes this? It's not a physical change, but it's a chemical change. How do you say it? A lot of heat energy is released. And you get soot and some of the gases. From these gases, you cannot get back the wax again. So that's a chemical change. So when a candle is burning, there are two types of changes happening simultaneously. What is that? Physical change as well as the chemical change. So children, this is it. Now bringing about one more difference between physical and chemical properties. There's one example, that is water and oil. Water and oil, what are they? They are liquids. So they are similar, you can say, no? Right, just by looking at the outward properties, okay, right, what are the outward properties? Melting point, boiling point, the next one, the hardness, what more? Then this thing called the fluidity, rigidity, these are outward properties which are called physical properties. Okay, right, so these two are liquids. If you look at them, they are almost same. Fluidity, both can flow, right, good. They are liquids, okay, right, okay. There are striking similarities. Both of them look similar. Physically, they are looking similar, but we'll see whether both of them are similar chemically. What I do is, I take oil, right, and ignite. Oil. Oil starts burning. It is combustible, right? Okay. Now I come here, take some match or something, and then try to ignite water, but water, it doesn't catch fire because it is non-combustible one and it doesn't support combustion. It will put off the mastic also. So what do we understand from this? They are looking, physically they are looking similar, but chemically the nature is not same. So children, so this is about physical change and chemical change. The different types of physical change and chemical changes that we see all around us, and the differences between the physical and chemical change, and a few extraordinary examples of physical and chemical changes. Hope you have enjoyed this chapter or this part, and look forward to the next part and present you. Thank you very much.